Hello there, Jacob here. I just wanted to show you what I've been up to here. So, I've been helping out with a FIRST robotics team for a few years here now, and I know that one of the things that's been developed in these last few years that I didn't have the benefit of as a student was a simulator. What it purports to do anyway is to simulate the physics of your robot such that you don't need to have a physical robot present in order to develop your software for it. Or, at least you'd be able to experiment with concepts, even if the virtual robot is fairly incorrect in its physics or whatnot. So what I'm trying to do is set that thing up. So real quick, I don't know if let's see, do I have a good way to do this? I want to show you. Do I really not have like a paint on here? Oh, I guess I do. GIMP might be okay. You know what, draw will be better, I think. Yeah, this is a real high quality presentation here. So essentially what the solution is, normally you have your Java code, or, whatever language you want, LabVIEW. And you take that and you run it inside of your robot. So, this is the robot, and it doesn't have a border, so you're just going to have to use your imagination here. Unless there's a quick way to... okay, well, we're just not going to... Okay, sure, we'll use that. And then we'll send it to the back. So normally you'd run your code on your robot like this. What we're doing here is we are putting a virtual robot inside of a simulator called Gazebo. This thing is going to manage where your robot actually physically is in relation to the field, and give your robot sort of a place to live. There are plugins that FRC, specifically the WPI lib guys, have written. Gazebo plugins. And what these do is they provide you a layer that goes between Gazebo and your code. So you run your code connects to these Gazebo plugins, and then Gazebo does its thing, does its simulation for you. And so these plugins include things like ultrasonic, DC motor, I don't remember what else. Those are the two that I care about just this second. Well, there's like a gyroscope. That'd be a good one. Probably accelerometers exist. I'd have to have a look. But anyway, so anywhere inside of your code where you would reference, like a Victor or a Jaguar object, like you normally would to talk to your motors, instead of connecting to your robot, this Java code would connect to this plugin, and this plugin would influence this simulation that Gazebo has running. So he does all the physics stuff. These do all of the communication between your code and the virtual robot. At least that's my rough understanding. We might discover it to be false, but yeah. So the instructions, if you go, I don't ever remember the actual address here, but okay, apparently it's wpilib.screenstepslive.com. You want to go to the 2017 FRC control system. This is always useful. It doesn't matter what you're doing for this control system. If you've never programmed for this control system before, here you go. This is not a complete manual, but it will give you a really good start. In our case, what we're trying to do is use FRCsim with C++ and Java. In our case, Java, because that's what our team uses. So we're going to click that link. And there's quite a bit of information here on how to install FRCsim. They call it FRCsim. It's Gazebo plus their plugins. And so this is, definitely go read through this stuff. I'm not going to go through all of it now. I've gotten to the point now where I have a version of Gazebo installed. And if you go through these, what you'll find is they're referring to a version of Gazebo. I think it's Gazebo 5, perhaps? 5 or later, it says. So if you download and run the script that they support, or that they supply, it downloads Gazebo 5, Eclipse Mars version 1, this particular older version of the C compiler or C++ compiler, and it bombs out halfway through because there's missing libraries, at least on my system. So I bet you if you were to install 1404, Ubuntu 1404, you might well be fine. The plugins or the packages might all be there. But I'm not. I'm running a modern version of Ubuntu. This 1404 business, it's pretty old. So what I'm actually going to try to do here is run a modern version of Gazebo. So if you go and look at the Gazebo website here, the latest version is 8, not 5. So I'm going to try it, run it with 8. I don't remember if Eclipse Mars is the latest or not. Eclipse. But that sounds old for some reason. Neon is the current version. So I don't have this thing where I need the old software. And this is something that we should figure out anyway, because, having to install a specific version of Ubuntu kind of sucks. So I'm going to see if I can get modern versions of software to run with these WPI-lib Gazebo plugins. So this may or may not end up being a giant waste of time. We'll see. This is more or less, this is not an instructional video. This is more about showing you the process that I took, documenting the thoughts that I had as I went along here. And documenting these errors and such, because I really can't be bothered to type this all up and make it into a nicely formatted web page or anything like that. This is just a lab notebook here. So what I'm doing here is I went ahead and I downloaded a copy of the WPI-lib, all WPI-lib repository here. This is just publicly available. This is, as far as I know, all of the code or most of the code that sits in between your software and the physical robot, or at least the operating system that you're running on. And so this will allow your code to talk to the outside world. WPI-lib is responsible for giving you like the Victor and the Jaguar and the autonomous periodic and teleop periodic, and even just getting your program running to begin with. WPI-lib is massively helpful for this. So this is a fairly extensive repository. If you go digging around inside of it, you can learn all sorts of cool details about how different layers of the system work. There's like PID loop, the source for how the PID loop actually works, what happens under the hood, and a bunch of other things. But what we're here for today is this simulation folder. So in case you've never done a git checkout before, you click this clone button, you do you grab this link, they give you that handy copy to clipboard button there, and then assuming you have git installed, so you should be able to see a git page like this. If you don't, probably need to go get that. I'll leave that as an exercise to the reader. And what I did is I actually ran git clone and then that link that I had just grabbed from there. And what that does is it grabs an entire copy of that code and its entire history down from their GitHub. And what I'm going to do here is I'm going to real quick run over and get my tater tots out of the oven, and then I'll be right back. Now, why would I not edit that part out? Because video editing on Linux is apparently not something that people do. That's a rant for another day. But in any case, definitely that's one of the spots where the other platforms are far, far superior to Linux. Video editing on Linux is absolutely miserable. Anyway, so what I did is I ran that git clone and it grabbed a copy of the source. And so that's actually, you'll notice this all WPI lib folder here matches up with their all WPI lib. And then the simulation folder, which is what we're actually interested in here. So if I were to click simulation, you'll see all of these folders. And then I went inside of the FRC Gazebo plugins folder. And so that's what this is here. So you have ultrasonic, DC motor. Let's see what all is here. Where am I? /WPI lib simulation. Okay. So if you look inside of that simulation folder, there's all your different folders inside of there. Now, there's DC motor, encoder, gyro, limit switch. If you've been doing, intermediate level FRC programming, you'll recognize all of these, except maybe that one. Now, I have a theory as to what this one is. I think this is a way for Gazebo to tell our code precisely what time it is in the simulation, because that has bearings on things like your PID loops. Your PID loops do care about time, but that's as much as I know about it right now. Anyway, each one of these is a separate plugin that will run inside of Gazebo. And in fact, if we look, I want to go into WPI lib again over here. Sorry, I'm fumbling around here. I really don't remember my way around here. Oh, it's in the simulation folder. Okay, so as you'll see here in simulation/plugins, this was the I should preface this all saying this isn't my first time around trying to make this work. I did follow the instructions that were on screen steps to some level, and a lot of this is the sort of artifacts left behind from that. This is the set of plugins that were pre-compiled and available for me to download and try to install. But if I leave them like this, if I leave them there, and how do I actually start Gazebo? No, I'm trying to remember now. I think I need to be inside of this folder. Yes, that's exactly what it is. This is an executable here. So if I go to run this, oops, that's okay. I can navigate my way there. /wpilib simulation FRCsim. So when you go to run that, that will start up Gazebo and try to get it running for you, and it will blow up in your face. That was bizarre. Okay, so I have gotten some strange behavior here. Is OBS actually seeing this? I think it is. I have gotten some strange behavior on trying to run Gazebo. I'm not entirely pleased with it, but it's mostly straightened itself out now. Yeah, so see that. There's a bug report right there. So FRCsim will actually start Gazebo on our behalf with plugins connected to it and whatnot. I believe it's actually supposed to be... shouldn't this be trying to run... Sorry, I had this running differently before. I'm hitting Control-C there. Okay, there we go. Yeah, that's not helpful. Now this is broken. I really feel like Gazebo has a few like bizarre race conditions and such here. Like, what is this? What? Where? Why did it go away? I don't think I closed that, but maybe I did. But I think there was a way that I had to invoke Gazebo. It would be on the Screen Steps website, and then it would be simulating GearsBot, I think is what I was trying to do. Okay, so the parameter to FRCsim is the actual world file. So if I were to run that with /wpilib simulation worlds GearsBot demo, if I run it like that, then you'll actually see a world load. Now this is not completely loaded, and that bothers me. And the way that I know this is not completely loaded is because I really thought, you know what, maybe not. I thought that the demo that I loaded before had more to it. Maybe it wasn't the GearsBot demo that I ran. I'm going to eat some of these tater tots while they're hot. So it wasn't that one. What's the other one? Oh, I ran Recycle Rush. That's what it was. Okay. So what this will do is it will preload. Yeah, that's what I wanted. So you'll recognize this if you've ever done FIRST. This is the field that we played on. This was a year that I actually wasn't around. Oh, wonderful. Excellent. Software is fantastic. Anyway, so this is the field that we would play on. This was Recycle Rush. It was a year that I wasn't around for, but So, and this is your robot. There's some game pieces here. This robot is what came with the simulation tooling from the WPI lib guys. So here I'm using the left mouse button and dragging to pan around. You can whoa, 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 and then you can scroll in and out with the scroll wheel. And then if you click the middle mouse button down and drag, it will rotate you around. I only knew to do that rotating around thing because I was using Blender 3D a while ago, and that's kind of what this interface looks like. I don't know if they use the same code or not, but so the idea here is that this robot will be described by these files. So this is what was supplied. I didn't create any of these. I don't know why they called the robot the Kraken, but okay. These, I believe, were exported from SolidWorks. I do not know anything more than that. This is just purely from reading through these files here. Yeah, you see, like, importing a model into Gazebo. That will explain how to set up the robots. We're not even going to go that far yet. I'm not worried about that yet. But this robot is a collection of motors and sensors and joints. And I don't know any more than that either. But that's where we're at. The robot, if you click on it, yeah, I see there's this hierarchy over here. I think these links and joints are Gazebo-specific terminology. You'd have to go look how they use them and how they have that documented. And then we've got all these different plugins, and you'll recognize many of these, like clock, gyro. These drives, if you click on them, you'll see it's libdcmotor.so. So that's actually the compiled version of these plugins. You know, this actually exists if you go and look in, not there, plugins. So these, like, there's libdcmotor.so. So we have part of the puzzle, but not the whole puzzle. Oh my gosh. My system is breaking. It is just breaking. Anyway, so if we look at this console window that we see, you know, this is where I started the FRCsim project with recyclerush.world as the parameter. And we see this failed to load plugin, and then libclock.so. libgazebophysics.so.6 cannot open shared object file, no such file or directory. And so what this tells me is this libclock.so was built against a specific version of this libgazebophysics library. And we've taken these files from that environment in which they worked and put them on a newer system. And so this is referencing a specific version that I don't have. I bet you if you were to look in my, I don't know if it's user share, user sbin, I don't remember which folder it would be, but one of those folders, you'll find a libgazebophysics probably, but it won't be .6. This is probably an old version, if I had to make an educated guess. So what I'm gonna do is I'm gonna actually see if I can take this source, because if you look at the source for these, it's not complicated. There's not much here. So I'm gonna see if I can recompile these to work with the newer library. So what they've done here, when you see these CMake files, you know you might well be, you know, home free. CMake helps you set up the the means of building this project into binaries. And I'm doing a very bad job at eating my tater tots. So you get to watch me eat those for a minute, because I can't edit video on this box. They're pretty good, just standard Meyer tater tots. Tater pucks. They're like the little discs. It's good stuff. Heinz ketchup. This bottle did bad things. It's one of those like no drip caps. I had to basically stand on the bottle to get it to let go at one point because the ketchup had dried onto the no drip thing. Anyway. So if you see a CMake project, often what you can do is run cmake dot. So in this case, cmake is a go look it up, go Google it. It's a tool that will generate a make file for you. A make file is a specific set of instructions that tell your compiler, build this file into a binary, build that file into a binary, take these two files, link them, put them in a specific directory. And that file is highly individualized to your system. You know, it really depends on what version of libraries you have installed. For more complicated projects, if you have, say, the example that comes to mind is Stepmania. It's a Dance Dance Revolution clone. That thing could do everything. There were like there was video background stuff. There was you could have plugins for different types of controllers. There were plugins to make it talk to an SD card if you wanted to save like your crazy high score. You could save that on an SD card and take it with you if you were so inclined. You know, it would support MP3. And instead of making you install every single one of those libraries to be able to build any version of Stepmania, what they'll do is they'll give you a bunch of switches that you give to CMake and say, yes, I want you know, video support. No, I don't care if it doesn't know how to network or it doesn't know how to play MP3s, things like that. And then it will build, based on the rules it has, a make file for you. So it's a two-step process. You run cmake dot. Now that dot says, we are inside of this WPI lib, simulation, recompile plugins, all the blah, 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 FRC Gazebo plugins folder. So we're inside of here. That's our working directory. Dot refers to the working directory, refers to right here. That's where I am. It's a relative path that points to the current working directory. And so what that'll tell CMake to do is create me files that are ready to build this project in this folder with the CMake rules that are here. I think it's the CMake lists folder that matters, or CMake lists file that matters. I don't know too much more than that, but so you run cmake dot, and I already did, but just so you can see what it does. Well, can I run a clean? Oh boy. Yeah, I don't know how to undo the operation. In any case, when you run it, it'll create you a make file, if everything goes well. Read the error messages. You know, comment if you want some help trying to figure out what you need to do to make CMake run happily. You may have to install it, for instance. I'm skipping over a lot of that stuff, but you know, it took me a while to learn it, so stop me if I get too far ahead of myself. But I've run cmake dot, and now I have this make file, and so what I'm going to do is say make. Now, that failed right away, and how I can tell is right here, fatal error in dcmotor.h, no such file or directory, and it's saying that it can't find gazebo/gazebo.hh. So, what that tells me is while the Gazebo library's binaries might have already been installed, and they probably were when Gazebo was installed, the header files that I need are missing. Now, what the Debian package people will do, and I think I'm on Ubuntu. Ubuntu is Debian based, so what the package folks will do here, the convention typically is, if you're working with a library, it's going to be lib, the binary name or the library name, so probably Gazebo -dev will be the actual it'll have the header files. It's there for developers, which is what dev stands for. So if you are looking to develop with OpenGL, you'll say maybe libgl or libopengl, I can't remember, -dev. Something like that. It's usually a pretty good guess the first time around. So what we're going to do is we're going to say sudo apt get install lib gazebo -dev. And it wants my password, so I'll supply that. And it says unable to locate. Okay, so I guessed the name wrong. We're going to say apt cache search lib gazebo. Oh, I didn't even spell that correctly. Alright, try again. Lib gazebo -dev. Okay, so we're close, but there's not actually a package to be installed. It says it's not available, but it's referred to. So it's not there. It's not in the repository, but we're close. So if we go apt cache search lib gazebo -dev. What did I screw up? Apt cache search lib gazebo -dev. It worked earlier. Alright, so we're just gonna say lib gazebo instead. And then there's the problem. Okay, so this is probably the package we want because we're trying to work with Gazebo 8. So libgazebo 8 is probably already installed. We can verify that real quick. Yeah, so that's already installed, but the dev files are probably not because we're running into issues. Uh-oh. Uh-oh. Alright, tater tot break. Gotta think. Gotta think. I hate when I gotta do that. Okay, so what it's trying to find up here is gazebo/gazebo. Now I gotta remember how to find this stupid thing. Right. I want to look. I need to remember which folder they put the it's user/include, I'm pretty sure. Okay, so that's the issue here. It'll be gazebo 8/gazebo/gazebo.hh. How did I know this? How did I know that this is just magically the folder to look at? Struggle, pain. If ever you have a file that includes something like this, where it's in angle brackets, it says include, and it's in angle brackets as opposed to double quotes, that's C's way of saying, and C++'s way as well, of saying, this is a shared header. This is not something that's specific to my project. This is something that any project can use. And so it should be installed somewhere in the system in common. That's what user include is. at least on my system and probably many Debian-based systems. So the issue here is that this project was built for an older version of Gazebo, and we're trying to modernize it. So it doesn't know to say Gazebo 8 /Gazebo /Gazebo.hh. So there's a couple things we could do. We could create a Gazebo folder that is symlinked. It's like a Windows shortcut to this folder here. But I tend to be kind of queasy about modifying anything that's in here because all of this was put here by an automated process. This was all put here by my package manager for me. It was put there by Aptitude. So we probably shouldn't be messing with what's inside of here. So what I'm actually going to do is I'm going to go into these files. Which one are we failing to build first? DC motor. So I'm going to go into DC motor, and I think it was the CPP file that was failing. And I'm going to edit this. It's not the CPP file, it's the header file. I'm going to edit this so that it says Gazebo 8 /Gazebo. And then I want to make sure that these other ones are correct too while I'm in here, because I'm sure they're not. So if I were to go looking, /physics, so Gazebo 8, Gazebo, physics. Okay, so that one does exist if I were to put the prefix on it. And then transport. Okay, so I do need to put this prefix on everything. It's a little bit annoying, but we'll get by. Is there anything else in here that looks wrong? I don't think so. So we're going to rerun this, and it's going to fail again right away because we didn't fix everything, but it should fail on the next object, perhaps. Okay. So actually it kind of looks like Gazebo, like their header, expects to be in a different folder than it's in. So this really well and truly, like if you look at this file, they've included Gazebo /Gazebo core. Okay. Okay, just kidding about the symlink thing. We're gonna do that. I think it's ln. I better look up the syntax of this before I get too far. Man, ln. Because there's I think it's a... What's a hard link versus a symbolic link? Oh man, this is going to get deep really fast. Create symlink. They want -s. Probably for soft or symbolic. Yeah, we don't need to make it contain the data. It can just be a shortcut. Yeah, so this is what we'll do. Q out of this thing. We're going to say ln-s. Well, okay, so this is going to have to be sudo because Linux tries to, at least this flavor of Linux, tries to protect you from modifying things that are inside of this user/include. Because you really don't want to mess with this stuff if you can help it. At least I'm fairly certain I can't mess with this. Yeah, that's kind of what I thought. So, permission denied. So, I have to be root to do this stuff. So what I'm going to do is say sudo link -s for symbolic, and then it's, what was it, source file, and then my file. So source file is the file that exists, and so what we're going to say is /user/include /gazebo8, and then we're going to link that to /user/include /gazebo. Gazebo. Okay. So what this will do is it'll create a shortcut. I'm pointing at the screen like you can see it. So that when you go to user include gazebo, you'll actually be going to user include gazebo8. And that's not quite what I want. I actually want to go to gazebo. I think. We'll figure that out in a minute. We'll see if this is true. Okay, so that link should be created. So if we go up here, we should see it. Bam! So this was designed so that they thought this folder was living inside of here, and now it looks like it is. That's what the symlink is supposed to do. So now, let's roll back the changes that I made. So I'm going to use git checkout -- star.hh, I think was the syntax I want. And then if I put that inside of quotes, it's still going to be angry. Oh, because it's in the H, not HH. There you go. So what I did there is, so Git is here to help you track changes to your code. So it's meant to make you make changes in a controlled manner. So you're not making folders called new, new to, really new, actually works, almost works. I've done that. I've been there. It's not fun. It's really easy to get yourself twisted up and ask yourself, what changed? As you can see here, I said git diff, and that tells Git to show me the difference between the latest committed version of code versus what is actually in this directory now. And since I changed these and saved it, but I didn't commit it, it shows me the difference. It says you took away these 3 lines and you replaced them with these 3 lines. So down here, when I said git checkout h and start.h, I said check out the version, the latest committed version of these files and replace what's in my directory with the latest committed version. And so now when I say git diff, nothing is different. So it actually undid those changes that I made. So now what I'm going to do is I'm going to say make. And it's going to fail. But it's going to fail differently. That's good. We're making progress. Things are changing. Now what is this? SDF/SDF, no such file or directory. So the gazebo header is trying to use SDF. Curiously enough, it's in single quotes. That bothers me a little. But yeah, because they don't have an SDF folder inside of here. Common SDF? No. that's not a thing. SD format? SD? Oh, look at that! So we're gonna have to do the same trick, I think. What file are they missing? Just SDF.h is missing. Yeah, so they want this file to be at user include SDF. So we're gonna do exactly the same thing with the link. And I'm just hitting up and down here if you're curious. We're gonna say user include SD format SDF to user include SDF. And we're going to rerun make. Oh, that blew up. Okay, so now we're missing something else. Ignition math.h. Do we have an ignition folder at all? Yes, we do. I don't understand why I'm having to do this. I don't understand why I'm having to do this. Sure, I'll do another one. Ignition. Well, I can't. So element.hh inside of the SDF library is referencing ignition / math.hh. And it's expecting this file to be here. And probably these files are referred to by this file. I don't know who packaged this, but they did not do a good job. Yes, this includes ignition, math. I don't think these files even exist. They don't. What in Sam Hill happened here? Why is this ignition? So they expect these files to be here. I'm gonna do a dirty thing, and it's wrong, and it's not the right thing to do, but I'm gonna do it. I'm gonna sudo copy /user /include math3 ignition. Okay, so look, user include, oh, I missed one. Ignition, math3, ignition, star. So I'm going to copy that to user include ignition. And I have to give it a -r flag, because emitting directory means you didn't tell it to go recursively. Alright, so Now we have a math directory here that has what we expect in it. Whoops, I'm losing things. Okay, so we have a math directory that has what we expect in it. We have a math header here. Alright, this is the end of the line. I'm not going any further tonight. Well, I don't know, maybe I could. So here's the issue. This file requires compile and library support for ISO C++ 2011 standard. And apparently it's not enabled on the compiler I'm using. Now, one of the hints that we got earlier was, if you look in the screen steps, FRCsim manually, they list out GCC 4.9. I'm willing to bet that the current version of GCC is not that. That's probably not even what ships with this version of Ubuntu. Now let's see, GCC --version. Okay, so it's clearly not using GCC. They might be using an older version of G++ though. Yeah, they are. Look at that. Unless these numbers have no bearing on each other, I have no idea. G++ compiler. Ubuntu. Trying to find the actual package. Yeah, this guy. So what came with what version of Ubuntu am I on? Oops. What version of Ubuntu am I on? I think I'm on Ubuntu. That'd be kind of embarrassing if I wasn't. I think it's -r. Oh, that's not helpful. Uname -a. Well, it says Ubuntu, but it doesn't say what version. .493. As you can tell, this is live. I'm not, this is nothing I'm going out of the way to stage and whatnot. This is completely live. I think it installed a PPA to be able to install this. I think that's what the script in here does. Yeah, so they have you install this guy, or to add this repository, and then install G++ 4.9 here. I really don't want to do it this way. Oh, so this isn't even calling directly on... Oh boy. This isn't even calling directly on GCC or G++. This is calling on CMake, which then calls on GCC or G++. Okay, well, I think I'm reaching the end of my mental faculties tonight, but software engineering, isn't this fun? Yeah. I don't know how anybody intended them to use that package like that. I shouldn't have had to symlink all that stuff. I'm sure I'm just doing something stupid, I just don't know what yet. Next video might be bashing my head on this some more, or it might just be trying to get Ubuntu 14.04 to work and going from there. We'll see. Have a good one.